Hey guys, how's it going? In this video we're going to go over the relationship between the energy, wavelength and speed of a photon. So let's get started. Following on from the previous theory video looking at the relationship between the energy and frequency of a photon, it says here that we now have a relationship for the energy of a photon in terms of its frequency, which was E equals hf, remember. However, just like for waves, each photon also has a wavelength and speed associated with it. So although a photon is like a particle of light, remember we're saying that particles can behave like waves and waves can behave like particles in this thing called wave-particle duality. So we're saying that even though a photon is a particle, it can show wave-like behaviors, and therefore it can have a frequency, a wavelength, and a speed, just like a wave can. And remember these three variables are related through this equation here, which we call the wave equation, which you saw in National 5 Physics, and it's V equals F lambda. And it says here that using the wave equation V equals F lambda, we can rearrange for F to get F equals V over lambda. So if we divide both sides by lambda here, we get F equals V over lambda. And what we're trying to do here is, starting with our relationship here, E equals hf for the energy of a photon, we want to see how an energy of a photon will be related to wavelength and speed. So if we take this rearranged form of the wave equation V equals F lambda, and we substitute it into our E equals hf, then we end up with this expression here, E equals hv over lambda, and that's just substituting in for the F. This gives us a new relationship for the energy of a photon in terms of its speed and wavelength. And this could be handy if you're doing a question which gives you a wavelength and a speed, for example, and asks you to calculate the energy of the photon rather than giving you the frequency of the photon. So sometimes questions will give you frequency, sometimes they'll give you wavelength, and therefore you need to choose which of these equations you use, whether it's E equals hf or E equals hv over lambda. And it says that this shows that the energy of a photon is directly proportional to its speed and inversely proportional to its wavelength. And we can see that from this equation, because if we think about the speed first of all, it's on the numerator of this fraction, so that means we can say E is directly proportional to V because it's on the top, which is this expression here, E is directly proportional to V. And if we think about the wavelength this time, you'll see it's on the denominator of the fraction, which is the same as thinking about 1 over the wavelength, 1 over lambda. So we could say that E is directly proportional to 1 over the wavelength. So we've got some conclusions here based on these relationships. So we could say the greater the speed of the photon, the greater its energy, which does make sense. And we could say the greater the wavelength, the lower the energy of the photon. So if you think about the wavelength there, the denominator increasing, then that means the energy will become smaller because of this inverse relationship here. It then says, remember that frequency and wavelength are inversely related, meaning that as one increases, the other must decrease. And this can be useful when doing calculation questions if you're told that one of them, say frequency, increases, and you need to think about what happens to wavelength, and therefore frequency would decrease in that case. And you can see this inverse relationship for frequency and wavelength by looking at this equation here, which we rearranged earlier for the wave equation. So you'll see that because we've got frequency is directly proportional to 1 over the wavelength here, ignoring the speed because it's a constant for light, we could say that as wavelength goes up, for example, the frequency goes down. Or as wavelength goes down, frequency goes up. Now just to finish, I've got a top tip for you here, which says that since photons are particles of light, they travel at the speed of light c, which is 3 times 10 to the 8 meters per second. This means we can rewrite the above relationship for energy and use this whenever we are dealing with the wavelength of a photon. So we have E equals hc over lambda, rather than this one here, E equals hv over lambda, because we're saying since we're always going to be dealing with light for this equation, V is equal to c, i.e. the speed of light. And you'll notice this equation relies now on 2 constants rather than 1. So we have Planck's constant h from the datasheet and c, the speed of light in a vacuum, also from the datasheet. So this means that if you're given a wavelength in a question, for example, you could then calculate the energy of the instant photon. Or if you're given the energy of the instant photon, you could calculate the wavelength of the photon. And it's worth remembering how we actually got this equation. Remember, it was from combining 2 other equations. So we had our E equals hf and the wave equation V equals F lambda. So it's up to you whether you want to remember this equation, E equals hc over lambda, whenever you're dealing with wavelengths and energies of photons. And that's because this is not given on the relationship sheet in the exam, or you can just use the 2 equations that are on the relationship sheet separately in order to arrive at the same final answer. So you'll find E equals hf and V equals F lambda on your relationship sheet. So let's say you were given the wavelength in a question and you're asked to find the energy of the instant photon. What you can do is use this equation first, rearrange for the frequency to get V over lambda, and use V as the speed of light and lambda that you're given in the question to find what F is, and then you can plug this into this equation here, E equals hf, where h is Planck's constant, and that will then give you your value of the energy. But what I'm saying here is that a perhaps quicker way and a sort of shortcut is to combine these 2 equations into this one here, E equals hc over lambda, and that way you're going to get to the answer a wee bit quicker. So it's up to you which of those two methods you would prefer. Now let's just look at what these symbols mean. So we say that E is the energy of the instant photon measured in joules, h is Planck's constant measured in joule seconds, and remember that's in your datasheet. C is the speed of the photon measured in meters per second, and again that's on your datasheet, and lambda is the wavelength of the photon measured in meters. That's all for this video folks, thanks for watching. If you made it to the end, I really appreciate it. Make sure to give the video a thumbs up, subscribe to the channel, and I'll see you in the next one. Take care.